Wait, I did something with Manu for that. This is not what I want. Ooh. Build. Alright. And then if I come here, I can do this. Right. Thought this would fix the issue, but let's see. Let's get some stats. 1, values, expressions, 2, scope, bindings and scope, 3, functions, ooh. Data structures, the hell, for functions and recursion, 5, pattern matching. Prereq is just going to be lambda calculus, right? Let's see, what do we have here? Did I share the link? Where's Safari? Twitter. Why am I sharing my Twitter DMs? Anyways, let's see. How's this guy? So, lambda calculus. I don't know how to write the lambda sign, so I'm going to pretend to use L, X, and then some expression, right? So where X is a value which could be any value or an expression. Yeah. So if we do this, let's have something like this, right? And then we can have this as E, and we can sort of apply this to another value, which then becomes, so then we have substitution, is that what it's called? Yeah. That essentially means, because everything is a value or an expression, we can essentially just pick if we want to evaluate this. If we want to evaluate this, then it just means anywhere that oh no, some e, anywhere that okay, let me do this. X is this, and E is any other expression. Like this. As well, right? So via, if we want to evaluate this expression, evaluate this expression. How do I even? Then we're going to replace for all instances of x, replace with some e. So let's say we have lx dot e, and then some e. We are going to have something like, we're going to have something like L. We pass some E, and then we're going to get E. And then the next level, something like L dot E, because we're not using L in the expression of E. So E is just another expression or another value. So this is just, this can be called, yeah, so if you pass some E to this lambda expression, that we have, then we are just going to get E back, because at this point E essentially goes away and L evaluates to E. Alright, where is this guy? One view. Who's this person viewing? Anyways, so for my notes, the first point is going to be one that values and expressions. So, at least in the context of, let's say, functional programming and OCaml, mind you, I have very limited experience in functional programming though. Obviously over here we can evaluate some more, other examples. So let's just say L, X, and then evaluate to X by X, right? So if we have this lambda function and we pass, let's say 5 to it, this just evaluates to L, passing 5, like substituting 5 into X 5 by 5, right? and then this should evaluate, the syntactic sugar goes away, so we get 5 by 5, which then equals to 5 times 5 is 25, right? If I am right. So that's just it. And then because E up there is also any other expression of the form V or another X, right? So we can also just pass another X dot X plus E, like this, right? So if we have to, oh no, let me do this one. I can use the variable here because we're actually evaluating. So if we want to evaluate this, and then we can have another Lx dot X. Let's say this is an identity function, right? So if we want to evaluate, it just means that we're going to have L, wherever we see X, replace X by Lx. The X equal to Lx dot X plus 1. So essentially what we are going to get is L. So that is going to be another lambda function that is there. So we get another expression back, and then we can further apply to it. So we can just copy this and further apply to, so if we say we're applying this to 10, we are going to obviously evaluate from the right, right? So we know that this gave us this. Da, 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 da. Why is, so we are going to first have to evaluate from the right. I've forgotten the exact term for this, but we're going to have Lx dot X plus 1 applied to so this is essentially going to be X. This is going to be 10 because X, L, lambda of X equal X means for any X, return X. And then we evaluate this. Because it's an identity function, we just get whatever inputs back. So now we have this, and then this can further evaluate to Lx equal to X plus 1 applied to our 10, and further reduce via substitution to 10 plus 1. Essentially that is the primary, oh, I don't have line numbers turned on. So anyway, in functional programming, okay, I have a blog post about this. Yes, and also obviously go and read about it. Yeah, so we have an variables like x, y, z, we have abstraction, and then we have application. So just like I showed there, lambda means a function, x is the parameter, e is the body of the function, which is an expression or another value. So just like I showed there, you have all this, you can go, and then it can get as complicated as much as you want, right? So then welcome to OCaml. I'm just going to, I actually started learning OCaml probably about a year ago, but I stopped to go and learn Haskell because I had to use it for my thesis, right? So can I do this? Let's see, okay, that's going to be fine. Yeah, so it becomes very easy. Now, let me start this way. At least in the context of OCaml, there are values and then there are expressions. Expressions evaluate to a value. In much more theoretical terms, probably also a type. And then you can get okay, so let's say x is equal to 42. This is wait, how do I call this? This is a value and also an expression, right? And every expression or every value has a type, even though we don't annotate it, right? This is going to be an int. But OCaml, you know, very smart people in the world have written their thesis and stuff, and they've been able to come up with, you know, good foundations, you know, type inference, type theory, hundreds of years spent on that. So you can just get away. I mean, you won't get away. Code won't compile if your expressions aren't inferred to the type that they have to. And then we can use let to also define, I don't even know why I'm just reading, square equal to x times x, right? And as you can see here, this essentially just means that we have a value x, like this expression evaluates to a value x that is of type integer and has a value of 42. And this here means that we have a value which is of type an int, no, which is of type int to int. It means we just return, like this is the parameter of the function, we take in an int, and then we return an int. Teaching is so hard. And so if we want to apply, if we want to like call the function, we can just call square and then pass x because we know the value of x up here, its actual value, right? And I'm probably going to talk about scope another later on. What else? I'm also forgetting what this is. But anyways, okay, that's fine. Oh shit, there's someone at my door. Stop streaming.